Hi guys, this is Carl. This is week 11, problem number 3. We'll go ahead and just dive right into it. A training center, wishing to demonstrate the effectiveness of their methods, tests some of their clients after different numbers of days of training, recording their scores on a sample test, and the data is below. The top row being training days, the bottom row being the correct responses. As you can kind of see, one training day, 3 correct, 5, 6 correct responses. There's a little bit of a trend there. So the question is, the regression model that calculates its correct responses is 2.372 plus 0.635 training days. The standard error of the residuals is found to be 0.731. Use the given results to find the standard error of the regression slope itself, the slope of this line, and show all three values that go into the calculation. So the regression of the slope, B1 is the slope, just for FY. B1, B0 is the y-intercept, if you don't already know. So what we're finding is the standard error, B1, equals the standard error of this is what we have, divided by this variation, the standard deviation, times the square root of n minus 1. So first off the bat, we need to calculate the standard deviation of the number of training days. We need to find this deviation right here, standard deviation of these numbers. And what you can see is, first we need to calculate the mean being the average of these groups. So we know the average is 7.6. And to calculate our standard deviation, it's actually the square root of the sum of x minus the mean, which means the x, each number minus the mean. 1 minus 7.6, which is our mean. 5 minus 7.6 squared. 9 minus 7.6 squared. See, that's what this e means right here. You're summing everything together, summing the difference between each value of the training days minus the mean of the training days. And then you're dividing by n minus 1. So we're breaking this out. N minus 1 right here, you can tell is 5 minus 1. Where did I get the 5 from? Well, there's 1, 2, 3, 4, 5 samples in this. So 5 minus 1 is 4. And as you can see here, it's a little bit long, but it makes sense as we discussed. 1 minus 7.6 squared, 5 minus 7.6 squared, 9 minus 7.6 squared. Again, 7.6 is the mean. We're taking just each value minus the mean and squaring it. So in the correct calculation for the remainder of it, as you can see, is just this number, the square root of this number divided by this number. The 87 divided by 4, and you get 4.6669, which is the standard deviation of training days. So invariably, just kind of give you a heads up too, we can also do in standard deviation, it's a little bit of a quicker way, but just to let you know, the init Excel function, based on a sample, this will give you the same as well. It should give us the same output regardless. And as you can tell, there it is. 4.669974 is our standard deviation. So either way works. We just wanted to show you rather just how you do it formulaically, but also in Excel, as you can see up here. You can do the same function in Excel, but sometimes it's real good to get a sense of the equation itself behind it, and kind of you see how it works in Excel. So back to our final question. The question of the purpose of our problem today is the standard error of the regression slope. So we have all the information we need. And so as you can see, all we do, we have our SE. So we're taking 0.731 and dividing by the standard deviation, which is this number, 4.669, times the square root of A19, which is our n minus 1. So do all that together, and our standard error of the slope is 0.078281. We just hope this helps, and just let us know if you have any questions along the way. Thanks so much. Bye.